The United States has conducted trials to validate the delivery of hardened-target munitions via unmanned platforms. In these evaluations, United States Army infantry drone teams successfully deployed a newly developed warhead engineered specifically for integration with small unmanned aerial systems. A live-fire event featuring the bunker Rupture and Kinetic explosive round BRAKER was carried out at Redstone Arsenal on March 26, demonstrating the system's ability to engage fortified positions. Notably, the trial followed shortly after the system's initial design and rapid prototyping phase, highlighting the Army's compressed development cycle and its push to field capabilities quickly in response to shifting operational demands. In this video, Defense Updates analyzes how BRAKER could transform lethality of U.S. small drones. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. A fundamental constraint on small unmanned aerial systems, SUAS, is payload fraction relative to available thrust. Multi-rotor platforms generate lift through high RPM propellers, but thrust scales imperfectly with size due to motor efficiency limits, propeller disk loading, and aerodynamic losses. As a result, useful payload is typically a small percentage of maximum takeoff weight. Increasing lift is not a linear fix. It demands higher torque motors, larger propellers, and greater electrical power, which drives up battery mass and reduces endurance. This creates a classic design trade-off between payload, range, loiter time, and acoustic thermal signature. For instance, doubling payload may more than halve flight time, while also increasing detectability due to larger rotors and higher power draw. Operational adaptations seen in Ukraine illustrate how users are working around these physics. Platforms like the Russian Molniya have been configured to carry heavy munitions, such as the TM-62 anti-tank mine. With approximately 7.5 kilograms, 16.5 pounds of high explosive, this payload can produce significant blast and overpressure effects, sufficient to collapse typical civilian structures and inflict serious damage on field fortifications. However, carrying such a mass severely constrains range and maneuverability, often turning the drone into a short-range, one-way attack system. From a systems engineering perspective, improving lethality without exceeding platform limits is driving innovation in warhead miniaturization and effect optimization. Instead of relying purely on blast, designers are increasingly turning to shaped charges, explosively formed penetrators, EFPs, and tandem charge configurations to concentrate energy on specific target sets. This is why relatively small RPG-7 class warheads remain effective. They use a high-explosive anti-tank heat mechanism to focus a metal jet capable of penetrating armor, rather than depending on bulk explosive mass. Even so, a single FPV strike may not guarantee a kill against modern armored vehicles, leading to the tactic of salvo or swarm attacks to achieve cumulative effects. Western programs are beginning to formalize these battlefield lessons. Efforts such as BRAKER within the United States Army reflect a shift toward integrated, mission-specific lethality packages designed alongside the drone platform itself. This includes modular warhead options, programmable fusing, impact, proximity, delayed detonation, and improved guidance integration to ensure optimal strike geometry, critical for shaped charge effectiveness. There is also growing emphasis on reducing collateral damage through controlled blast profiles and directional fragmentation, which is particularly relevant in urban or complex terrain. Properly engineered, these munitions can enable small units to deliver precision effects against fortified positions or light armor without relying on artillery or air support, significantly enhancing tactical independence while staying within the physical and operational limits of SUAS platforms. The BRAKER effort focuses on developing a compact yet high-effect warhead tailored for deployment from small, maneuverable unmanned aerial systems, balancing lethality with the tight payload constraints of lightweight drones. Development progressed at an accelerated pace. In early March, Armaments Center engineers initiated the full-cycle concept design, explosive pressing, fabrication of the casing, and system integration for a warhead intended for a low-cost, expendable one-way attack drone. Within a short time frame, compatibility and transfer trials were carried out at Picatinny Arsenal, where roughly a dozen units were assembled. One of these was subsequently employed in a controlled test against a representative bunker structure, validating basic performance. Following initial verification, the prototypes were transported to Redstone Arsenal for a live demonstration before senior Army leadership. These efforts align with the Army's Transformation in Contact initiative, under which a variety of unmanned systems are being procured and distributed across brigade combat teams. As drone adoption scales, corresponding demand for tailored munitions, optimized for size, weight, and mission profile, is expected to expand. From a technical standpoint, BRAKER employs a combined effect mechanism. The munition leverages kinetic energy at impact to penetrate surface layers, such as soil cover or structural materials, before initiating an internal detonation. This sequence allows the explosive effect to be contained within the target volume, significantly increasing pressure and damage to enclosed spaces like bunkers or fortified positions, while reducing energy loss to the surrounding environment. In parallel, the United States Army introduced the Picatinny Common Lethality Integration Kit, a standardized interface designed to safely and reliably mate lethal payloads with UAS platforms. The kit was engineered by specialists at the U.S. Army Combat Capabilities Development Command Armaments Center, enabling rapid integration without extensive redesign of either the drone or the munition. The objective is clear in intent, yet challenging in execution. A lightweight, powerful, and lethal warhead that could be deployed from a small, agile drone. Engineering teams from the U.S. Army Combat Capabilities, Development Command Armaments Center, and Project Manager Close Combat Systems collaborated to develop the munition, leveraging additive manufacturing techniques to accelerate design and production cycles. Program officials have underscored that demonstrations such as BRAKER are the culmination of sustained investment in munitions science and the deep technical expertise resident within the Armaments Center. The successful deployment of a drone-delivered warhead against a designated target not only highlights the operational viability of such systems, but also reflects the Army's ability to rapidly design, fabricate, and integrate capabilities in response to emerging battlefield requirements. According to Anthony Sebasto, Executive Director of the Munitions Engineering and Technology Center, the accelerated timeline was made possible by long-standing investments in both enabling technologies and core competencies at the Armaments Center. Army Colonel Vincent Morris, Project Manager for Close Combat Systems, stated, "Our Picatinny team went from concept to live fire in 2 weeks. BRAKER proves our ability to rapidly develop and safely deliver devastating effects from small, unmanned aircraft systems. We are now creating the architecture with Picatinny Common Lethality Integration Kit and the small universal payload interface for industry to scale this critical warfighter advantage." Looking ahead, the next phase of development will focus on integrating BRAKER into the Picatinny Common Lethality Integration Kit. In parallel, the program is expected to support scalable production in collaboration with industry partners, enabling broader deployment across operational units.